Hi, everyone. Thanks for joining today's webinar, Whodunit, Identifying Suspects Through Digital Evidence. My name is Julie O'Shea, and I'm the Global Marketing Manager here at Black Bag. Before we start today, there are a few notes that we would like to review. We are recording this webinar, and we'll share an on-demand version once it is complete. If you have any questions, please submit them in the questions window, and we will answer them at our Q&A at the end of the webinar. I'm excited to introduce our speakers today. We have Matt McFadden and Stephen Billery. Matt McFadden is the Director of Training at Black Bag. After 17 years in law enforcement, Matt honorably retired as a police sergeant from the Clovis Police Department in California. For 13 years, Matt conducted digital forensic investigations and supervised their department's high-tech crime unit. He has provided expert testimony in state and federal courts for digital evidence examined in child exploitation, murder cases, fraud, and many other crimes. Matt holds several industry-recognized certifications in digital forensics and incident response. Stephen Billery is a forensic engineer at Black Bag. Prior to joining our team, he worked in law enforcement since 2002, with a focus on digital forensics. His background includes creating 2 digital forensic units and conducting digital forensic examinations for criminal investigations of all types. He holds a CFC certification from IASIS, a GIAC certified forensic analyst, and has over 800 hours of DFIR training. He has lectured at several universities throughout the US and has delivered several digital forensic training courses around the world as well. Thanks for joining us today, Matt and Stephen. Matt, if you're ready, I will hand it over to you to get started.
Hey, thanks, Julie. Thanks, everybody, for joining. We've got a presentation here today. I'm glad to be presenting with my colleague, Stephen, here. We'll be walking you guys through Whodunit, identifying suspects. As we progress through this, we're gonna talk a lot about things. The first thing I want to show here is we're used to our software working for us. We're used to the pretty view, the nice things being handed to us, and we're gonna kind of push back against that a little bit. We want to take an investigative approach to our evidence. We want to know our evidence. We want to be able to get a case and be briefed on the case and know where we're going to look for this stuff, not just press buttons and let the tool tell us what the evidence is. We should be driving the tool. The tool should not be driving us. We need to bear in mind where this evidence is stored. How is it stored, in what structure or format? And once we're able to get that data, what does it mean to us? What does it articulate? Because we don't want to just present evidence and assume it means something. Are we testing it? Do we know? Have we attended training, validated this stuff so that we know what we're doing? Because a lot of us, when we get to the next view here and we're looking at hex data and ASCII representations of stuff and parsing structures, sometimes it gets out of our comfort zone. And we want to be here to encourage and help people along the way, because it's a hill we got to climb to understand this stuff to move forward. Our presentation today, there may be some things we'll share that are technical, and there may be some things that maybe are not so profound, but kind of help us connect the dots a little bit. Some of these techniques are very easy techniques. Some of them may be a little bit more complex and tying 2 or 3 bits together to put something in line. Now, the case brief I'll be walking through, my colleague Stephen here will have another, but I'm investigating a subject that is involved with government intelligence related to satellite intelligence, and they're suspected of stealing stuff. But as this subject's under investigation, roughly within a few days, an anonymous threat comes into the work, and there's rumor that there's going to be a workplace shooting involving specifically a Steyr AUG rifle. And so we're investigating the subject's computer to see what we can kind of tie in. So obviously we're going to look at interviews of the suspects, witnesses. Some of you guys may be out there involved in that. And I would strongly encourage you guys to be involved in the interviews if your duties do allow. If they don't, please brief with the investigator to know that the information you're going to need for the case, because otherwise you're walking a little bit blind into your investigation. We want to have as much a context as we can to kind of guide what we're looking for. There's also a difference too. We're going to be looking a bit at profiling the system and then also profiling a user and or users to try to track down, what's going on here and are any users information be able to boil up there for us. So looking into our case scenario, we're moving ahead and kind of profiling the system here. Now within Blacklight, we pretty much go up to system up over here, and we are looking at the registry. It's all parsed out with the standard processing items. Looking in the all button there, we can navigate down to this path. HKLM for Hive Key Local Machine, and we're going into the software registry Hive, and a very standard one, Microsoft Windows NT current version, one that a lot of us know. Inside of this, we're going to find, who was the registered owner of the system, maybe the registered organization. Here we see an actual Outlook account that Microsoft has seemed to want to force us to use lately, and we got to find to use a specific one. But we find James Crease here, and that is our suspect that we're looking at. So little note, doesn't get us a ton of information, but it helps us get a good email address for him that we may want to do further discovery on, but also getting a full name for our suspect here. Looking a little further, what has this machine been named when it was set up? If it's at a home, do they name it something that's going to help us identify to him? Sometimes we're forced in a case where a suspect is like, that's not mine. I don't know what you're talking about. That's not my evidence, or that's not, not my evidence, not my computer. And we want to be able to tie them closer to it. Well, we can go look in a couple other areas. The security registry Hive, we go down under policy, and this I'll call it POLAC DMN, and we go down there and we get the host name of the system that we would just type host name in a command line. That's what we would see. But unfortunately, in our case, we get desktop. It's like, great, thank you. Not a whole lot here to work with. We can also look at some network settings on the system. In this same area of security Hive policy, we just scroll down a little bit further and we see the POL PR DMN, and we're going to find the domain that the system is attached to on the network. Well, again, we got another strike here, work group, not a whole lot. So we're going to have to dig a little bit further. Another area is related to network. Again, Blacklight always provides you the path here inside the registry area. So when you navigate, you know exactly where you are. We have HKLM inside the Hive Key Local Machine system. We identify a control set, which I'm going to go look at specifically later how we identify that. But under services, TCP/IP, parameters, interfaces, we get the GUIDs for the different type of devices. And we get information in here in the registry showing us a FiOS router.home. So again, it could be named whatever it wants to, but this has given me an indication this laptop was likely on a home use, or last connected at least when the registry was written to a home system. I get IP, subnet mask, all kinds of information if I need to tie something back to this system. So again, nothing too profound, but just kind of wading through and scraping up the evidence that we can find here. Now, getting into a more of a user-specific investigation, we can probe the system in many other fashions, but going over to the user, following our line of whodunit, one of the more simple tasks is we're always faced with users out there. In the ladder from Vista on, we have the users folder, and we're looking at who we got here. Now, in this situation, we've seized the laptop from a family environment. So back with my buddies back at the police department, we'd always be going, okay, who's our suspect? Because sometimes you're walking in and you don't know who it is. And we have an Audrey, Dana, we have our default. Defaults are going to be where when we create a new one, that's going to be the template by which the new profiles are created. And then we have James. Don't neglect public. Public's that area that, all of them are shared, the public desktop and other areas. And then we got James and Russ there. This is really simple, nothing profound here, but just navigating in quickly and kind of triaging the user profiles. We look at Audrey and we see, well, nothing really sticking out on the desktop, documents, downloads. As I poke through here, nothing substantial. And I go over Dana, nothing, and pretty much the same kind of default stuff. Now, a lot of people, may say, well, this is pretty straightforward. I should get this. And I just want to step back and say, I've been given cases where they wanted a second review of a case. And in one specific case, they were looking, it was a child exploitation case, and they were saying, hey, we had analysis, nothing was turned up. Can you look at this? And when I looked at the case, I ended up finding video evidence of child exploitation material stored under a user profile under the videos folder that it was missed with the software. So these techniques, you get in here and you manually just navigate. It just takes you seconds to kind of triage these. So going through, we've got Audrey, Dana, kind of, not that we want to neglect these profiles, but not really heavy users at this point. As I'm profiling Russ, I start to see into the documents a little bit. It looks like Russ' student calendar. Is he a student? Is he in college and high school? Getting some information here, but not a whole lot still. Step on over to James, and I can't even, I couldn't even screenshot the bottom of the documents folder contents there. So as I'm going through those, I'm starting to see James is a pretty active user. I can go into app data, local, I can look around. I'm going to find a lot of significant stuff with James. I'm seeing Fortnite, he's gaming a bit. Got some uTorrent going on. That's another concern, specifically with receiving or distributing files. But he's kind of getting in my sights here and trying to find out what's up with him. Going further, as you're going through the user profile, granted, be always cautious and compliant to what the scope of your search is. Don't exceed it. We may have a search warrant signed by a judge or magistrate, and they're like, you can only look at this or these dates and times, and obviously abide by that. But if you have the leeway to look, start scanning through things, look through the pictures, gather intelligence. This picture sticks out to me in the investigation because it's a very unique structure. So I might want to go, where is this? Because is there a date and time that can help me tie the suspect to this location and or to this computer by possession of this image? Simple things I can do is extract the file and just upload it into Google Images. And I've gone from, well, I got a church looking thing to this is St. Patrick's Cathedral in Dublin, Ireland. If I go a little bit further and look into the suspect's records as far as work and time off and travel, found out he did make a work trip to Dublin, Ireland during this date and time. Now, if I want to try to get down to the exact date and time, I got to go back to the image. We all know the EXIF metadata information is stored there. I get dates and times that can be stamped in there. They can be altered as well. I can get information. Blacklight allows you in the hex view or going over to strings. I can see it broke out a little bit nicer. I see a make. I can see, image format. I get an exact model. I've had cases where we have a suspect we take into custody. We seize the digital item, be it a phone or camera or something from them, and we've been able to tie it directly from them of taking illicit images and having the media in their possession with the metadata matching the device from which it was taken. Again, a pretty simple technique, but it can really help tie your cases together. Moving on, other images. Look for things that may help you put a suspect in an area. This one's just a train. Okay, got a train. What does that mean? Well, where is this train in the world? It's a lot of our child cases come down to identifying who did it or where is this stuff at, or maybe we have a traveler case here. Well, where is this train? I see an enterprise sign. It looks like, is that a bathroom, green symbol back there? Is the track identifiable? But I'm looking at that 9004 on the train. And some people are thinking, well, it might be kind of hard to turn up, but if I literally just use the words that I know, Dublin from the St. Patrick's Cathedral, type in train 9004, I've got this matched as the Dublin-Belfast line for the Irish Rail. And that's exactly accurate in this case, is what this train was doing. So sometimes the internet can be our friend as we dive in and start looking at these things, of looking at an image where I don't know where it is in the world, and I've got it down to pretty much a pinpoint location. All right, other ones, another simple technique, and I promise we'll get a little more technical here. Simple ones like this too, don't neglect these. I've had cases that had things very similar to this, where you're saying, okay, I see some fuzzy trees. They took a pretty bad picture of the sea, as the Irish Sea. But play with your images and adjust them. Use video editing things, because as you adjust them, other things can jump out. I got a suspect's head there with a pretty unique shape. I've got a gentleman off to the left side. I can make out the nose and other things like that. It may not be prolific, but we had a major case made where a suspect pled guilty to decades in federal prison, and we were able to identify him based on an image exactly like this. They didn't realize that they had snapped. Going through the profile, pay attention to things and how they're stored. Again, nothing prolific here, but I end up finding this work folder and nothing in it. And you may just go, okay, nothing in there, move on. But I want to take note of this, because why would someone make a work folder and not put anything in it? They may just not have had time, but what if something was there and now it's not there anymore? We're going to come back and visit that in a second. Poking around, do I have other attributions to my suspect? It looks like this is a folder called his brother's place. Looks like his brother's involved in karate. Can we validate that? Can we tie this back to the suspect more? You'll find things in images and in user profiles that may not stick out. Like one case I had, we ended up finding a couple resumes. One resume belonged to the suspect. The other one belonged to some random person we had never even heard of. We thought, and almost dismissed it. Had my partner check out the second resume of who this person belonged to, went out, and this person ended up being a very viable witness that broke our case open and led to a lot of leads and got our suspect able to get him into custody. So don't neglect these things that just seem maybe not related at first. Really pay attention to these. Another technique is get inside their brain a little bit. If your scope of your media and your digital forensic scope allows, get in there and use the tool and look around to see what they're interested in. Looking at the media, I can limit all media within a user profile simply within Blacklight by going out there and clicking the media button. And of course, I can classify and do our image scanning and categorization. But over here, I have a menu that pops out when I click the menu button, and I end up with a filter here. I hit plus, I click path contains, and let's go for the user profile Audrey. I go in through Audrey here, and as I'm looking at Audrey, I find that it looks like she's into volleyball a little bit. Nothing much more. As I go and I look to profile Dana, I end up finding Dana. Looks like she's into hairstyles, maybe some baking, arts and crafts and stuff. I go in and look at Russ. Looks like Russ is our gamer. I got some gaming applications here and some other items. But as I get over to James, I start to find some weapons and ammunition and other things like that. As you scroll through these and get in their internet content, things like that, you'll find out what their interests are. You'll find out, what they're attributed to. So one other example, we had a subject who was really into racing, and we were trying to identify the suspect, and we walked into his office on site, and we saw all these images of racing posted on the wall. So it helped us to know, ooh, this is that user. As we look further through James's profile, just by the filtering, we ended up finding images of satellite intelligence. So it's like, now we have a computer based on the network interfaces that's been attached to a home network, but now we have some satellite intel images potentially from his work that are on what appears to be a home system with home users on it. So now we're starting to get somewhere. Let's dive in a little deeper here. Let's look at some more registry stuff. Starting to scratch the surface here. Blacklight has the significant. Now, under the all tab over here, we're going to get all the registries, the local machine and current user. But under significant, we pull out a lot of the COM-DLG 32s, recent docs, run MRUs. These are the run commands that are stored. These are all things, and notice it breaks it out by into user.dat by user. So all I have to do is just go expand these, and then the next screen, I've just expanded James into user.dat, and I'm in the COM-DLG 32 looking at a bunch of MRUs. And the most recently used, and this is the listing of all, breaks them out by extension, but I can see a lot of things here. I've got Minicats, looks like in a 7-zip archive. I've got a JK work. Our suspect is James Crease that we found out from that registered owner. Bitcomet outgoing. Outgoing's never a good thing when you're looking at things that are being stolen from work or taken from work. But so this gives, and there's uTorrent again. So we're kind of getting into we're profiling the system a little bit more, but per user, under the user James's into user.dat. So going back into we want to go back in the system, but I do want to back up and talk about if we have different control sets. So we'd go into the system registry hive, and the local machine, we'd go into select. Now under select, you'll see the current. The last current control set will be logged. We have one. Well, in this case, we only have one, so it makes it kind of easy, but we do want to know where to check should we have two of them here. But going into the system registry, we can also get a little bit of, we hear the term WPD, Windows Portable Devices. Burrowing down under this, the control set, enum, SWD, and we have this WPD, Windows Portable Devices, a bus enum. We get USB store and USB type information. Well, in here, we end up lucking out with a friendly name of the device called JKman. So I would want to know if this is the suspect's home system, has this device attached to the work system? Where else is this device attaching to? JK man again, JK James Crease. How is this tying into our case? So we're going to go a little deeper now, chase some investigative lines here using some file system information and getting a little more technical here. Now, chasing that line of that work folder. Remember, we found that work folder that was empty, and we're going, scratching our heads. Well, could there have been something in here? Well, let's dig at it a little bit further. In Blacklight, I would go click the metadata tab, because what I want to do is to go after the file system. I want to identify the file system ID, or identifier, which is the MFT record number, because we're on an NTFS volume. So we're going to put this number in our short-term memory. Mine doesn't last that long much anymore, but I've got 240006. And then I want to go down and look at my sequence identifier, sequence ID. I've got 3, because these MFT records get reused, and this is, the 1, 2, and 3rd instance of this record. So I got file system ID 240006 and sequence ID 3. So now I'm going to go over to my buddy, the USN journal. This is an NTFS, item, a functioning item, the update sequence number, USN journal, that's going to help us track files being updated. And these are the MFT records that are being updated, and it's going to log it in here for us. Software uses this program with the file system, so it doesn't have to scan everything. We're going to go in here, we're going to do a little investigation here. So what I'm looking for is, you remember that 240006 sequence ID 3 was the folder. So I'm interested in what would be in that folder. So I'm going to focus over here under the parent MFT record. So the parent MFT record is 240006. So I filter on that, or sort on that, and I look for sequence 3. That's the one I'm interested in. And I'm going to look over here at what the entry is in my update sequence number journal. And I find it looks like a folder, because I don't have a file extension on it, but I got stuff. And what I'm going to do is grab the MFT record and sequence ID for stuff, and I want to sort on that and look at that a little bit further. So I'm going to just flip the view here, and what I've done is just click sort on MFT record and looked at all the ones that match the stuff MFT record that used to be stored in that work folder. And where is it now? What's the history? What's the update sequence of this entry? And as I look across it, it's this beautiful evidentiary item is I end up with dates and times that I have a sort here all within a second. I have a rename old name, rename new name entry for reasons, and a couple little changes here. Well, we see a name change. And a lot of us will recognize, oh, well, okay, this is the old Vista on recycle bin mechanism, where it's changing it to the $R. And if I look over here, I see it is now in the recycle bin. And if I were to scan over to that parent MFT record, I would see it's no longer in the work folder. It's in the recycle bin MFT record entry. The other thing that helps me is this security identifier. Remember, we have S for security identifier. We have our version, our authorities, and all this information to help me identify a domain or system. But then I get the RID, the relative identifier, 1001. We want to find out who that is. Who's moved this over there as the user of 1001. So I want to go research the recycle bin a bit, and I want to go look at which user has done this and moved this stuff folder over. So going over, Blacklight parses out the SAM registry real nice for us. If we go into account usage and user accounts, I see user RID 1001, I've got James and some information about his user profile. So back to James again. Now going over, I can go dig into the recycle.bin, but nicely within Blacklight, I have actionable intel, file knowledge, and trash items. And I get all of these entries, and I have a folder named stuff with a bunch of items that used to be stored there. I'm just sorting by the original path and looking at all these items that used to be in this folder. Now, if I go and actually look and start clicking on these media items, which are JPEGs that have been moved here, as I do that, I start to see a Steyr rifle that has been moved over to the recycle bin that used to be in his work folder. So now we're making some connections with our case, and we can attribute all these to the user Jane profile. All right, one other look here, a couple more things, and then I'll wrap up. The user assist, we're going to go into user specific execution. User assist is a really nice, it's stored in the ntuser.dat, which is unique per user, and I can identify what users are, launching. by this. It's helping to populate, the start menu area and stuff to help the user launch their items. So I basically am looking at James, and as I'm going through James, uTorrent sticks out. That one jumped out at us before. I remember seeing uTorrent, and we can go across and see a count which it stores and a last modified date and time that we have an entry here for. And we've get January 25th, 2019, and we have 18:26:40 hours. Now, this is all parsed nicely for us in Blacklight under the actual Intel program execution. We have a lot of support built in here, but user assist is a tab we'd go through. Now, I want to demystify this a bit, that Blacklight is working for us. If I were to go look at the raw registry, okay, this is where it's stored under the intuuser.dat. I've got the Windows Current Version Explorer User Assist. It's stored in ROT13. It's technically a monoalphabetic cipher, but it's more of a light obfuscation that we see. This is actually the EXE obscured by RKR, but Blacklight does this interpretation for us. So it displays it nicely here. So what we want to do now is, seeing that uTorrent has been launched, we have a last date and time here of January 25th, 18:26 hours. How about we just run a filter within Blacklight? And we can go over here, and inside of this, we just run a date created filter, real easy, with the little easy drop downs, and say, let's show January 25th, and let's go look at that 18:26 hour and see what's going on. And immediately I start finding satellite intelligence images on a home-based system. I look down here, I end up with UT. My best guess right now would probably be he's indicating uTorrent, but now I have usscrypt.torrent. I got all kinds of things jumping out just by a simple technique of looking through a timeline scroll here or analysis. I can go in and look even further. I end up finding jQuery, or the JavaScript queries, the parse tree structures of information related to what appears to be a torrent application in these HTML files. I can even go further and limit by date created and just say, and how about the name contains torrent? I'd put a colon in between these for the or, USSF or satellite. And now I'm right into the hardest stuff, right in that same minute. I've got satellite intelligence, I got actuals.torrent, all kinds of information. If I look in these torrent files, I'm seeing the de-encoded data, and I'm seeing satellite intel, thermosphere, exosphere, troposphere, all kinds of satellite intelligence type stuff that I need to tie back to the work, that these are items that were probably taken from the work and they're being distributed. So Chase, one more line here, and then I'll turn over to my colleague, Stephen. This is jumping out at me. I saw it before a little bit. I may not have called it out, but we get this folder path, James, we can attribute to him. And then we have logs, st outgoing. He's kind of burrowing it here in a folder path, but I have Jan Spicoli J, and then I've got my images and media here. So this Jan Spicoli J is kind of like, what's that? What does that mean? So diving into that a bit, thankfully, we end up having some volatile data to dig into. We got a memory capture from the system before it was taken down. Blacklight nicely parses this stuff out. We have a lot of our processes, library sockets, handles, drivers, all kinds of things are parsed in here. But even better, we can run, or not better, but just another nice way to run a search across it is content searches. I can run these from the processing functions within Blacklight, and I can just click these and go. And this one, I went ahead and went with internet searches, and I click that, and I can see my keyword here of what it's breaking out by words of internet searches. And I, again, can go use my filter over here. And using my filter, I put in Spicoli. It's just part of the term there. You got to be careful not doing too much, so you limit yourself. But just by typing in Spicoli and the resolved content searches on this volatile memory, I end up finding it looks like a Google search query equals Jeff Spicoli. So now I've got a Jeff. I got a first name of Spicoli J. Looking even further, what if I go over to email addresses and run the same thing? I end up with some email addresses to interrogate further. I got Spicoli, looks like, is it jrhs@gmail.com. And as I'm scanning around in context here, blow that up there for you, I'm actually finding some uploads of Google Documents, some talking here, plan dude, here's the plan, work with it or I'm out, more information to chase. So I'm going to stop there with my part, with my case investigation, and hand it over to my colleague Stephen here, and let him take you on a little bit of a ride with some Mac OS and iOS user-based investigations.
Thank you, Matt. A quick introduction for what I will go over. Many times in our examinations, we may need to help out and put the pieces of the puzzle together. Today, we're going to focus on using information or artifacts for identifying a user. When you're doing your analysis, are you using all of the information available to you? Do you have information that confirms that this device was being used by an identified person? Was the device actually located on the person? Was it located on the scene? Or is it just not being claimed? As an examiner, do we build identity schemes using known or unknown identities, or discovering completely new identities that we didn't know about going into the examination? What is the data telling you? Let's reveal that truth. And then let's take that story, because one day we may be telling that story in court. The pieces of the puzzle, do they always come in the same shapes and sizes with every case? You may need to think differently in order to find the value in an artifact. So we're going to start with an iOS device running 13.1. A quick overview of our criminal activity. We're going to have a time frame from March 2018 to September 2019. It's going to be in reference to vehicle burglaries and vehicle theft. So far, we had 3 persons of interest, but nobody wants to claim this iPhone that we're investigating. We started our examination on the scene with Mobilize, so we're able to quickly take an extraction of that device and preserve that information, so we could later take that information back to our lab for examination. So we're going to look at some of the information from that extraction as we bring it into Blacklight to analyze it further. This is usually a good starting point for examiners for the name of the device. The name of the device usually will be the first person's name that is utilizing that device. So we could be starting from there, but in this case, the 6 is the name of our device. It's not really useful, doesn't have any identifying significance for us. But we have a phone number here and we have a serial number, so those are some unique identifiers. As we continue looking through that information, we can get further unique identifiers or information that will help us build identification for this user. So the carrier, we have an AT&T service provider. We have that phone number again and that serial number again. We also have an IMEI number, and we have a Wi-Fi and a Bluetooth address. These addresses should be unique to that device, and they can be utilized later if we have some logs from different artifacts. The time zone is unique, but it's not real specific. So we have a time zone of America, Toronto here. So the last time this device was set, that time zone was in that area. We're going to keep that in mind as we go through this. Now we have some unique values. Let's start building the identity profile. So where's a good place to start for identity profiles within a device? The user accounts or account usage. So here we're looking at Facebook accounts, an Instagram account, Kik, and Twitter. Right away, we're seeing a unique ID for that Facebook account, and we're seeing some unique names, or what could possibly be the user's names. So we have a first and last name of Josh Bennett. So with that unique last name, we're going to take that unique name and we're going to start building that profile. Real quick, just an overview. Our first name for our possible user is Josh, last name is Bennett. We also have a phone number. The geographical location is possibly in the America Toronto time zone. And we have an email address. Lastly, we have that Facebook ID. What we did in order to start chasing down and seeing what identifiers we could get for Bennett, we did a quick index search within our case after we processed it. And what we have is some results with multiple types of data. We have contacts, we have some files, we have internet history, we also have some messages. So let's start digging into those. We go straight to contacts and we find Josh Bennett's contact information and we dig into the details of that contact. So as we see, we have a picture here, which may be of Josh Bennett. We can open up that picture, we can look into the picture and see if it has identifying information within the picture that will help us maybe verify out of the 3 suspects we have if one of them may be Josh Bennett. Continuing through, we now have a home phone number. So we have a text plus handle. We have an AIM handle. We also have a physical address in California. So now we have an address in California and we have a time zone of Toronto. Not sure what's going on here yet, but let's continue going through this and maybe we'll figure it out. One of the files that we had in our results was a log file. This log file came from an application folder. That application was Pinger. For those not familiar with Pinger, Pinger is an instant messaging application you can place on your devices and use it for communicating. The log file that was left under the application for Pinger had some easily readable text in there. So when we did our Bennett search, we found some artifacts related to the first name Josh, last name Bennett. We also found that same email address that we'd seen before. We now have a zip code, but this zip code is different than the physical address we saw earlier. And we have a possible birthday. As we continue going through the next file, we have a Skype P list. So this is on the application for Skype. And that P list, if you dig down into some of those entries, is going to have the full name of Josh Bennett again. And then we have a Skype handle here. That Skype handle could be useful later. The last file we're going to go through is a preferences P list. This preferences P list is related to Apple services. We see here Apple ID, iCloud, iTunes, and the App Store. We have a cached title and a cached username, that same full name, Josh Bennett, and that same email address that we've seen multiple times already. So with these pieces of information, we could use those Apple services for possible third-party identification. We could reach out to Apple and get some information from them that may verify who Josh Bennett is. Not only that, but wait, we may have additional sources here because if they're utilizing Apple services, Apple may have some information stored about our user here. But for now, we're going to put a pin in that and we'll take a look at that later. So let's update our identity profile again. We now have an additional physical address. We have an AIM handle, a home phone number. We also have text plus handle, possible date of birth, another zip code. And if we look up that zip code comes back to San Jose, California. So now we have 2 instances of California and a geographical time zone of Toronto. Still trying to figure out why these things exist. iCloud email. That's the email we're actually going to be focused on. This email is going to be very important for our investigation as we go forward. So let's continue looking at our results. Our results for the messages are going to be iMessages that were saved on this device. And the chat we're looking at right here is back from July of 19. If you look through that chat, there'll be some content there. We're also going to look at the context and not just the content of these messages. So let's dig into that just a little bit. So if we look at that first attachment, it's going to be a picture. It has a file name. We could take this and we could run with it. And we could actually go into our tool and discover where this file name exists in all of our artifacts. We also have a text RTF file that's being sent through messages. The name of it is Allied Parts. Our case is surrounding vehicles. Maybe this is a list for some vehicle parts. We don't know yet. We would have to open that file up and take a look at the content. Besides the content, our context we have in the messages, hey man, got that sheet you need to send Taz. We also have Taz Zillen as a sender. This is going to be a new identity. This is not our existing identity unless Josh is Taz. But we may need to branch off, make a new identity, and continue building that identity as we go forward with our investigation. We also have hotrotter@icloud.com email address because iMessages will allow you to send messages with an email address. So we have a possible third identity that we need to build upon. The last results we had were from the internet. So we're going through our Safari internet artifacts, and they're going to come from 3 SQLite databases: Bookmarks, Browser State, and History. Right now we're looking at the bookmarks here, and as we go through the bookmark entries, first one we see is Toronto, the official website for the city of Toronto. So this may relate to and support that time zone artifact that we located earlier. We also have some vehicle information here. Vehicle websites like Car Part, Vindicoder, Auto Parts, and another Vindicoder. So we're continuing to support that vehicle interest here. Lastly, we have a Facebook entry for what looks like might be Josh Bennett's Facebook page. The next thing we'll take a look at is Browser State SQLite database, which contains some last sessions. Those last sessions are going to be those multiple tabs that you'll have open in your Safari browser, because as a user, you're opening up new websites and you don't want to close that last website. So you'll just open up a new instance or a new session. So these are going to be some things that may have been recently utilized by the user, or he or she may be saving for later so they can add it to a favorite, but they just haven't gotten that far yet. As we go through these sessions, we'll see more vehicle URLs. We'll see a lockpickshop.com. That's an interesting URL. We may want to ask them or have the investigator follow up with them on why they have this in their last sessions of visiting websites. We also are seeing more car parts and airbagcenter.com. So if I am a thief and I'm stealing cars and I'm parting them out, we may have a mechanism for getting rid of those parts. And what we may be seeing here is instances of those and artifacts of that. We also have some searches from DuckDuckGo. We have a broken side window is the keyword search there, and stolen car. See some interesting terms, and we'll just keep those and pocket those with some artifacts as we build up. Lastly, we're going to look at history. The history one, you will also see some more car URLs like auto123. Again, you'll see the DuckDuckGo broken side window entry. And lastly, you'll have that Facebook entry, which appears to be Josh Bennett's Facebook page. This ends our exploration of the index hits for Bennett and those results that we received. I want to revisit and explore further into those iMessages that we saw earlier. Sorry for the interruption of this webinar, but let's take a quick break from all the analysis to remind our viewers that this is not Hollywood. Though we may have shown and walked through some really good artifacts, the production of this analysis thus far may have taken upwards over an hour to conduct. Real examination and analysis takes time versus webinar. Stay tuned for your regularly scheduled barcast. Back to it. Let's dig into those messages. Let's go explore. We want to see what those contents were. We had the graphics being shared, we had the voicemail being shared, and the text message. So let's go explore those files, specifically that graphic, that picture, that may help us. So for this picture, we have the content, right? We can open that up if we locate it, but we also have the context. So the message that's related to it. Lexis apparently made these built-in clips to hold your sunshade in place. Who knew? Now, what does that mean to us right now? Nothing much, but if we continue on and we actually look at that graphic, now it has some meaning. So we see a Lexus in a parking lot that has a visor on it. It's actually under the windshield, under the windshield wipers. It's kind of different, right? So this picture, which was sent in the message, this picture has metadata inside of it, which could give us location information. But how accurate is that location information? Nowadays, these devices, as they update and keep updating, they're getting more and more accurate for that location information, but there's still variables that come into play that may make it not exactly where the picture was located when it was, not exactly we know where it was located when it was captured. So how can we verify that? Are there other ways that we can verify where that picture was captured? In some cases, a local investigator, they may have the resources to be able to go out to that site. They'd be able to may be able to visit this parking lot and actually see, oh, this is the angle, this is probably where they were standing. So you can provide examples of that and see that in some captured pictures and videos you may have in your cases. But what if you can't do that? What if the graphic was captured somewhere that you can't visit reasonably? Or what if you handle cases that spread jurisdictions? So is there another way, without leaving our desks, right, within our labs, that we can possibly go and try and attempt to verify where a picture was captured? Absolutely. We're going to explore that. So if we go to Google Maps or some other mapping service, let's take a look at that with the information that we have from this picture. But before we switch over to the next slide, take a look in the background of this Lexus, not the focal point of the Lexus. In the background, you'll see on the right-hand side a building with some windows. You'll see a couple of trees or shrubs. You'll also see a light pole or two. And if you look really hard, you'll see an on-exit ramp that could be useful for us later. So if we go into Blacklight and we look at that location data, it'll show like this. And we'll be able to see that the location appears to be somewhere around San Diego, California. We have our longitude and latitude here, which if we wanted to, we could take that longitude and latitude, we could copy and paste it into a machine that has internet access if our examination machine doesn't have internet access. If our machine does, we can click on this button here to show it in Google Maps, and it'll actually push that over to the website for us instantly. So let's take a look at that. Let's dig into it and see if we can determine where this picture was captured. So from Google Maps, you get a better view of where this may have been captured. You have some reference points here now. You have an interstate, you have some businesses in the area, and then you also have the drop pin for the longitude and latitude that's possibly that parking lot. But I want to look further. If available, Google Maps has Street View. When we click on Street View, it'll bring us to that top left picture for that long and lat, and it'll actually show part of that parking lot. If we start panning around that view, then we'll see this larger view here on the right-hand side. We may now see some interesting landscape that looks familiar from the graphic that we have. So can we compare this? Can we look at these and say, reasonably, this picture was captured here? Absolutely. So as we compare some of these graphics, on the left-hand side, you have a cropped version of the Google Maps Street View. You can see the building with the windows that looks very similar to the building with the windows that's in the background of our Lexus picture. We also have a tree or shrub that's there. Might have been a different time of the year because the leaves aren't here in the Google Maps picture, but in the picture that was captured here, it has leaves. We also have the light poles that look very similar. And if you look real hard, you can see the on-exit ramp. Finish following those hits from our index search. This will be the conclusion for our index search results. I want to revisit some of those additional sources. That thing I had said we want to put a pin into. So we want to look deeper into those. Let's take a look at those artifacts. What were those artifacts possibly related to? In this case, we're going to be talking about iCloud and backups. First thing we're going to look at is an iCloud recents plist. Once we locate our recents plist, we can look at the entries here, and we will have a last iCloud account person ID with a string behind it of some numbers. We also have a last iCloud account was logged in Boolean of true. Does anybody log in with a numeric string? No, absolutely not. So what does this mean? What value does this have for us? Well, as we continue looking through an additional plist that has iCloud information in it, we will see that same value. And that same value will be near and related to the same email address that we had seen earlier. So we're actually relating those items to where we're further identifying this to the user. So this ID, what can we do with it? What is it? Well, Apple uses this ID extensively. And with using this ID, any kind of requests that are sent to them, they will associate with this ID. If you send them an Apple ID email, they actually look it up and find the ID associated with it. So in this case, it's time to send off some requests so we can get some additional information and get some additional sources of information from our case. The next thing we're going to look at is backup information. We're going to look at a backup LDP list. And the first thing we're going to look at in the entries of that P list are the cloud backup enabled. In this case, it's false, so it's currently off. Now, we may or may not have iCloud backups, but in the state that we did our extraction of this iPhone, we don't have it on. The next thing we're going to look at, the last iTunes backup date. I'm going to take that string of numbers and we're going to interpret it. When we interpret it with the Cocoa WebKit, we're going to get a recent date. So now we know that this iPhone was backed up recently to some other device. Well, an iTunes backup means a physical connection. Well, if we're physically connecting to something, what can a user connect their phone to? So in this case, we may be looking for a MacBook Pro, an iMac, or a Windows machine that's running iTunes. Could be a variety of different pieces of evidence that we're looking for. So also, we will have to take into effect the encryption that will be turned on because we have our Boolean here that has a true for will encrypt that backup. We may need a plan for that ahead of time if we're going to go get further additional pieces of evidence. So what's the next step here? This may be a pivot point in our case. We may need to go talk to that investigator, tell them we found some information relevant to getting additional evidence items. Time to look for more evidence. And how do we go about doing that in an investigation? Sorry to interrupt this webinar, but let's take a quick break from all that analysis. To remind our viewers, this is not Hollywood. The outline here is what would have to be done in real life in order to gather more evidence. Thank you. Now let's proceed and take a look at one more interesting artifact that was located from the laptop that we did have time to analyze. So from our Mac OS on that laptop, we're going to look at one artifact of a picture, a screenshot. If we look at this picture closely, you'll see it appears to be from a browser, and the title slide is broken side window, similar to that search term that we had looked at earlier. So how did this picture get here? Can we determine by looking at this picture on the Mac OS if it came from the internet or if it came from a user? Let's dig into that. Here's some file system information about that graphic. We have our name, we have our path in the downloads folder. We have some normal dates and times you'll see off of Mac systems, but additionally, we have extended attributes for the quarantine. We'll see sharing dig. This is a very good term to look up when you're looking for a particular transport of a certain type of communication. We also have a where froms. This where from strings has Josh Bennett in it and the 6. Well, that's interesting. So did this come from the 6 iPhone that we're examining? Let's look into it further. As we look at the parsed out metadata, the spotlight information for this graphic, we can dig into it and we can start to see some good information, like an application identifier for mobile slideshow. The display name is Josh Bennett. The sender handle is an email address similar to the one we've seen so far, but it has iCloud.com in it. As we continue looking further into that spotlight information, we can actually start to determine the recipient and the sender of that file. And further down, of course, we have our transport entry, which names AirDrop. And additionally, another where's from for the 6. So what are we seeing here? We're seeing an interaction. We're seeing an interaction between that iPhone and this MacBook that we're analyzing for an AirDrop exchange. Well, this wraps up my section. I really hope everyone enjoyed and get something out of attending the webinar today. If the information in this Whodunit webinar piques your interest and you may want to learn some more about this, please visit our Blacklight training website. There's a preview of the new website that's been newly renovated and the URL for that training. I'm going to hand it back over to Julie if there was any questions.
Thanks, Stephen. So we have had a few questions come in, and we are almost at the top of the hour, so we'll just answer a few here, and then if you didn't get your question answered, we will follow up with you individually. So I'm going to start with the first one. Where does Blacklight get the information to populate the trash items?
Likely related to the trash items I showed there with the slides I was going through. We have mentioned the $R file that, we call it the recycled or the file that's in there. The $I, think of it as information, is like a buddy file or shadow file that gets created with it new when it gets moved to the recycle bin. Within that, you'll get the information that Blacklight will parse related to the file information that it shows.
Great, thanks, Matt. Next one, if we can't get airdrop information from Spotlight, is there any way to locate the airdrop exchange?
Yeah, it's possible. We can, if you can get into the unified logs or pull out the unified logs from a device, whether it be a MacBook Pro or an iOS device, we can look through some of those logs and possibly get some transaction information there.
Thanks, Stephen. How about how reliable are the dates and times in the Windows registry?
It's a good question. It depends on a lot of the mechanism writing them, and we've seen a lot more sometimes latency of actually writing some of the registry values, although they tend to be logged pretty accurately. I would encourage everybody to test on a system to do the known actions that are occurring and look at them. In the tests that I've run, quite a few are occurring within a second, sometimes up to 2 to 3, depending on the mechanism that's logging them. Some are pretty instant. When I mentioned as far as the write, you need to be careful, really not related to dates and times, but you need to be careful. Are you collecting disk-based stored registry, or are you collecting live registry, which is populated in RAM or memory, upon your collection? So we're seeing with Windows 8 and 10, with the latter operating systems, that sometimes you almost have to log out of the user profile or shut down the system to force the registry write to the disk-based registry. It's not exactly a forensic action you want to undertake, so I would strongly recommend collecting memory because a lot of your registry data can be stored there or analyzed from there.
Thanks, Matt. And are our products going to be compatible with Catalina?
Yeah, I was actually just talking to tech support recently. There's going to be, to my knowledge, they're still running tests and making sure. In our courses that we're running, we're actually running tests now too. We're seeing pretty good success, but for an official support, that's going to come from our basically our development department soon. We want to be sure it's functioning and that we don't send people to say it's all clear and then there's some road bumps ahead. But to my knowledge and talking to colleagues, so far it's looking pretty good, but not officially supported quite yet.
Great, thanks. That makes sense. And we are at the top of the hour here, so I think we will wrap up for today. And if you had any other questions, we will answer them individually. Thank you, Stephen and Matt, for walking us through all the different ways investigators can connect a suspect to the evidence. As a reminder, yes, we will be sending out the recording of this webinar, so stay tuned. And if you're interested in learning more about any of our products, services, or training, you can email sales@blackbagtech.com. And then, of course, be sure to follow us on Twitter, Facebook, YouTube, and LinkedIn, which is @BlackBagTech, and subscribe to our blog on our website. Thanks again for joining, everyone, and have a great rest of your day.